For this lesson, we're going to be continuing our review of grade 10 material as part of the grade 11 introduction to the course. Today we're going to be looking at completing the square, which is an important skill when it comes to dealing with quadratics, but it also contains a lot of algebraic elements that can be quite useful for a variety of situations. So it's actually a very useful skill to master, not only for when you actually need to complete the square, but because it actually contains or it forces you to become comfortable with a lot of other elements of algebra that are going to be important in this course and going forward. Now, completing the square is a very specific skill on its own. Why would we complete the square? That is something we do when we have a quadratic equation in standard form and we want to go to vertex form. So completing the square has to do with this binomial term that is squared. So completing the square has to do with creating that term. So the first thing we need to do is to recognize and to become familiar with or recall our familiarity with perfect squares, because that's what this x minus h all squared, that's a perfect square. Now, from our discussions on expanding and factoring quadratics and binomials, there are two forms for a perfect square. One of them is when we have a positive, and one of them is when we have a negative inside the brackets. So when we expand that out, we're going to end up with either a positive or a negative. And that can give you your first hint on where to go. So for example, this first one, part A, I have x squared plus 10x, and I want to know what is the value to go here in the blank that will make this a perfect square. Now, you may want to fill in the blank first, or you actually may want to fill in what's in the brackets first. Now, one thing we can fill in the brackets immediately is a plus sign, because we know that when there's a plus sign here, there's a plus sign here. So this plus gives me that plus. Now, the other thing is if I take a look at the way these things relate to each other, a squared plus 2ab plus b squared. X squared plus, well, the x and the x squared, they relate to each other. That comes from this a term. But then we've got 2. So the key here on finding out both the term inside the brackets and the term, the constant on the end here, it has to do with this value of 10. So what we actually want to do is we want to take that value and divide it by 2. You can see here that it's twice as big as it needs to be. So 10 divided by 2 is equal to 5. And so this value is going to be 5 squared. So 5 squared, which takes us here to 25. This value of 5 is what goes here. X plus 5 all squared is x squared plus 10x plus 25. Now, if you're not seeing that, if that's a little too much to take in all at once, I'm going to illustrate this in another way in an upcoming slide. So just bear with me for a moment. So let's go through that same process again. I have a minus sign this time. So that means this is going to be a minus sign inside the brackets. I have negative 18, so I'm going to take negative 18 divided by 2, which is equal to negative 9. So that's x minus 9. That negative 9 is right there. And then negative 9 all squared is equal to 81, and that's what goes there. So there's my perfect square. So let's take a look at this in another way. And I'm going to use algae tiles to illustrate this. So again, I've got a similar situation here. X squared plus 6x plus a blank is equal to some perfect square. So let's show you where this comes from. So let's make a perfect square. So when we do algae tiles, our goal is normally some sort of rectangle. In this case, it's actually going to be a perfect square. So how can I take 6 x's in a way that ends up with an even number or the same number of x's on each edge? And the answer is I'm going to put 3 on each edge. And that's where that divide by 2 idea comes from. If I take 6 divided by 2, that's equal to 3, and I put 3 on each edge. And now, well, what's left over here? What would fit in here? And if we space it out, you can see it's 3 wide and it's 3 tall. And so that's going to give me a total of 9. And that's where we get the 9 here comes from the fact that I've got 9 singles here. And this is x plus 3 because this is x plus 3 on this edge and this is x plus 3 on this edge. You can do the same sort of thing here algebraically using the area model. So if I start with x squared, now I know that I need to make between this square and this square, I need to make 9. Or sorry, I need to make 6x. So how do I do that? I put 3x here and I put 3x here. That gives me x plus 3, x plus 3, and 3 times 3 is equal to 9. So this is how you would do it with pen and paper or pencil and paper. This is how you do it with actual algae tiles. Let's take a look at another algae tile example. This time I'm actually going to take it a little bit further. I'm actually going to complete the square. So I'm going to start the exact same way I did before. X squared minus 4x. Well, that tells me the minus 4x tells me I need negative 2x and negative 2x. Half of negative 4 is negative 2. So I put those negative 2's on either side. Now, the other thing I've got here, this is x squared minus 4x, but this one also already has a negative 3. And to do this using algae tiles, I actually just put those off to the side. X squared minus 4x minus 3. So you can see I have the original expression here. But what I want to do is make a perfect square quadratic. But in this case, I'm going to complete the square, which means I'm going to put it into vertex form. So the question I should ask myself is, what do I need to put in this bottom corner? So this is x minus 2. This is x minus 2. So what happens when I take negative 2 times negative 2? And this is a mistake that's easy to make with algae tiles. Negative 2 times negative 2 is actually going to give me positive 4. So there is my positive 4, but I can't just make plus 4 appear out of thin air. I have to balance that with negative 4, and I put those outside of the square. They don't fit into the square. So now, if I look at my overall result, I have x minus 2 all squared. That's the square. I had to introduce this negative 4 to balance the positive 4. And I already had negative 3, so that gives me a total of negative 7. So this is going to be the perfect square quadratic is going to be x minus 2 all squared, and the vertex form overall is going to be x minus 2 all squared minus 7. Okay, now let's move away from the algebra tiles and let's just talk about doing this strictly using pencil and paper. So to go from a standard form to a vertex form, we have to force. That's what we're doing here. We're forcing a perfect square into our equation. And in order to do that, in order to work with this full quadratic equation, we need to be able to work with the perfect square form. So, as I already illustrated previously, what we want to do is take half of 12. 12 divided by 2 is equal to 6. And then square that. 6 squared is equal to 36. So x squared plus 12x, that's going to be plus 36. But we're not allowed to make a number appear out of thin air, and so we have to also subtract that 36. So we end up with this, x squared plus 12x. And as we recognize, the number we need to make this into a perfect square is plus 36. But we're not allowed to make that appear out of thin air, so we also have to subtract 36. And then I already had a negative 7. Now this part in the middle, plus 36 minus 36, well, that's equal to 0. So I haven't actually changed this equation. I've just taken this part in the middle, which is equal to 0, and I've made it more complicated. Now the reason I did that, the value in it, is because I have created these first three terms. Well, those first three terms are a perfect square. X squared plus 12x plus 36 is actually the same as x plus 6 all squared. So that's x plus 6 all squared. And then, so this is y equals negative 36 minus 7, which is what's left over. That's this part on the end. Negative 36 minus 7 is equal to negative 43. And you can see that this is now in vertex form. Let's do the same thing, show you the same thing, except for this time I'm going to look at it from the area model perspective. So let's take a look at this one. We've got an x squared. I need negative 20x between these two squares. I need to make negative 20x. Well, the way that I do that is I need negative 10x and negative 10x. Half of negative 20 is equal to negative 10 on each side. And so when I write that out, x minus 10, then now that actually tells me, without having to do this stuff, without having to do quite as much in my head, I mean, I would argue that both of these are about the same level of difficulty, but one of them might speak to you more than the other. So this I know is going to be negative 10 times negative 10, and that's going to be positive 100. But I'm not allowed to make that appear out of thin air, so I also have to put in a negative 100 over here. And if we actually complete this, let's actually write out, this was plus 15. So let's put our plus 15 over here. And so you can see we could actually go straight to our final answer here. Y is equal to, we can see that the perfect square here is x minus 10 all squared. And then that's going to account for everything in the square here. And then we had minus 100 plus 15, which gives us an overall minus 85 or negative 85. Now, could we have done the exact same thing here using this technique? Absolutely. What happens when the a value is not quite so simple, meaning it's not a 1? In that case, and this is an understandable place where students get tripped up, what you need to do first is you actually have to remove whatever that a value is. If it's not 1, and that includes just something as simple as negative 1, you have to factor that a value out of the x terms or the variable terms. They're not always going to be x, but the variable terms. So y equals, I'm going to actually factor out negative 1. Normally I would just show it as a minus sign in front, but I want you to see I'm taking out the negative 1, leaving behind, well, what is negative x squared divided by negative 1? That's positive x squared. What is positive 6x divided by negative 1? That's equal to minus 6x. Now some people will actually factor the negative 1 out of all three of these terms. Not only is that not necessary, it actually ends up, it can create work for you. And we'll see that down here when we do part F. So really I recommend that you only factor it out of the first two terms, and then you just leave this last term, and I'm going to exaggerate that by giving some extra visual spacing here. This constant term, you just kick it off to the side. You have to keep it in the equation, but we're not focusing on that. That's not the focus of what we're trying to do here. Okay, so now what we're really focusing on is this x squared minus 6x. Well, now we're back to a simple trinomial. We're trying to make a perfect square of that. So we take negative 6 divided by 2 is equal to negative 3. And negative 3 all squared is equal to positive 9. So this is equal to x squared minus 6x plus 9, which is the perfect square x minus 3 all squared. So now let's see, how does that come back to here? Y equals negative. Now I'm actually going to change this round set of parentheses into a square set because I'm going to be having multiple layers of brackets. So the first thing I'm going to do, and I'm going to take my time here, so I'm not going to rush anything. I'm going to write x squared minus 6x, and now I'm going to complete the square, which I found out before I needed a plus 9, but I can't make plus 9 appear out of nowhere, so I also have to subtract 9. That's the end of my square bracket, and then plus 13. So y is equal to negative bracket. Now, x squared minus 6x plus 9, those three things together, that's our perfect square, which was x minus 3 all squared. So I can write that as x minus 3 all squared. Now I've got this minus 9 still inside the square brackets, plus 13. I think I'm going to need a little bit more room here to actually do this properly. So let's move all of this stuff down a bit. Okay, now the next thing I'm going to do is I'm going to multiply this negative sign, which is really a negative 1. I'm going to multiply it into that square bracket to get rid of that outer square bracket. I want to put this into vertex form, and we're not quite there yet. So negative 1 times this bracket, I'm going to leave the negative outside the bracket, x minus 3 all squared. Negative 1 times negative 9 is going to be plus 9. And then I had that plus 13 that I'd kicked outside and left outside for a while. And now I've got my final answer where I combine this 9 with this 13, and that gives me plus 22. And so now I have this in vertex form. This negative value in front, that's actually the a value in front. So this is telling me that a is equal to negative 1. Let's go through that same process again, except for this time I'm going to use the area model. I'm going to bring this over, make it a little bit more predominant. Okay, so let's start with, well, the first thing we need to do, we still need to do that factoring of those first two terms, because you can see here this a value is equal to 3, and that's no good for completing the square. So what I'm going to do is I'm going to factor that 3, and this time I'm just going to go straight to, actually, does it matter if I go to the square bracket? I guess it doesn't. I'm going to factor that 3 out of the x squared. Well, that just leaves me an x squared. I'm going to factor that 3 out of a positive 12x, and that's going to give me plus 4x. And then I've got my plus 11 on the outside. So now what if you wanted to do this with the area model? Now I would take this part, which is the x squared, plus 4x means I'm going to need a 2x here and a 2x here. And now I ask myself, well, what do I have to put here? And this is going to be x plus 2, x plus 2. 2 times 2 is going to give me plus 4, but to balance things off, I need a minus 4 on the outside. So this result, this tells me what goes inside the square bracket. So what I've got here, this is the contents of this square bracket. So let's go ahead and write that in. Y equals 3. And what is the square bracket? How could I write the square bracket based on what I've got drawn over here? I have an x plus 2 times an x plus 2, which is an x plus 2 all squared minus 4. There is the square bracket that I came up with using the area model, plus 11 on the outside. Now I'm going to expand this 3, or distribute this 3 into the square bracket. Well, the 3, I'm not going to put it into this round bracket. I'm just going to put it in front. So that's x plus 2 all squared. 3 times negative 4 is negative 12. And now we can bring in that plus 11 on the end and do our final simplification. X plus 2 all squared, negative 12 plus 11 is minus 1. And this is now in Vertex form. So you can see here I've done it a few different ways. You can do it from a purely algebraic perspective, as I did here in example E. You can mix and match. So if you prefer, you can use the area model if you find that visualization is a little bit easier for you to get your head wrapped around. So you do have options here on how to do it. If worse comes to worse, especially if you need to remind yourself on how to do this or see a really nice visual model, you can go back to the algae tiles. But you really need to be able to do this on paper. Being able to do it just with the algae tiles, that's not sufficient for the kind of algebra you're going to need to do in this course. And that's it for this review of completing the square.